Hello, dear viewers. Welcome. Today, I want us to extract foundation or putting load values from Staad Pro, and from there we can design eccentric putting because that is a challenge for me. So one of the advantages of Staad Pro is integration. You can be able to integrate it either with manual calculations or other softwares. So we are going to extract for foundation load values or putting load values from this model here, and we're going to design eccentric putting. So and also we're going to design axial putting in Excel. I mean that will be it. Okay, so please let's start. The first thing I'm going to do my analysis. Let me run my analysis. Okay. Wait a bit. I want to check my model support true. So my supports are fixed. Okay. Now I run my analysis. Save. So this is the first step, run your analysis. You can watch my other videos on how we design this model, analyze how I solve the various errors that you might face when using Staad Pro. So zero error, zero warning, one note. So we can go to post processing, or we can stay, or we can just click here. Now I'm going to go to view, that view. I'm going to select, I'm going to pick node cursor and then select my foundation nodes only, and then I'm going to view and then selected objects. So I've only selected the nodes using the nodes cursor. So I'm going to view my nodes only. So I'm going to view the plan view. So to see the reaction, you just need to click there. First of all, it is important. Let me first go to my model. It is important when you go to post processing to select which node you want. So I'm going to select combination. I'm going to select the most critical combination. Okay, so I'm not sure which is the most critical combination. I'm going to take this combination. Then okay, so that combination. Then my reactions. So you can see my reactions. So we can take any of the nodes. So I'm from my model, my perimeter line is in this side. So this is where my perimeter line is. So this is where my footings are going to be eccentric. So I'm going to pick. You can pick. Let's go back to analytical model. You can pick. Let's say, because these ones are too close, I can pick that one using select node cursor. and then I'm going to post-processing, and then I'm going to reactions. I'm going to pick that, and then I'm going to view. First of all, I will just pick that view selected objects. So that these are my load reactions at this node. So we are going to design eccentric putting for this node. So first of all, I have the design spreadsheets here. You can quickly do just. Let's first start with eccentric putting. So let me extract this. Okay, now I will need my RCC design spreadsheets. Currently don't have Excel for eccentric putting. So I will need another software to integrate another software called Prokon. So we can just compare. We will use Excel to compare the results of Excel with those of Prokon to see how accurate our results are. But we cannot design eccentric putting using this Excel sheet because they have not provided Excel for eccentric putting. So to do that, we need to use another software called Prokon. So you can see Prokon. You can download this software from the official site, and you can have a trial version. Then let's start. So this is the way it looks like. So we will go to concrete. We will go to, from here you can see option. This is continuous beam slab. So you can see base here. So we go to base. Okay. I will load in my default values. But we're going just to edit. We're just going to go through everything. So let me assume my base is 2 meters, then 2 meters, and then I only have one column. If it's a combined putting, you can just use the 2 columns, but this one is not a combined putting, so just use one column. So my first column, my column here is 225 by 350, 225 by 350 millimeter. So this is just 0.225 by 0.335. So you can see if you are having circular column, just put 1, you will assume to be the diameter. Now it's not circular. So actually it's like that. Okay. My base is 2 meters. So we need to have an eccentric putting where this column is lying here at this edge. So to do that, you can see you can divide this column. 225 divided by 2 is 112.5. So you can just use the calculator. Let's go to utilities. Then I'm going to use my calculator. So 0.225 divided by 2 should be equals to 0.125. And now this distance from here to here is 1000. So it will be 1 minus answer. So this one will be 1 minus 0.1125, right? So is equals So this is what we're going to input. Negative 0.0075. Now we're going to input that here. Negative 0.8875. 8875. Now you will see that the column will move right here. Okay, so now that's the way our column looks like. So my base depth should be, that depth for me is too small. We just use 0.5. And then from this spreadsheet, you have what we call load takedown, column load takedown. So I'm going to open. So, okay. Yes, close that. So, continue, next, done. So, I'm going to go to load. This is called load takedown. You can just do load takedown to get the unfactored, this cumulative load in the column. So I think if you have this Excel, what you are going to fill in here is pretty obvious. So the distance, the story height is 2.85, slab is 150, the beams, if you have beams in every direction, so column above, column below, all that is just pretty obvious. So I'm going just to use here 500. 500 for me is okay. That is the serviceability bearing pressure. So we can just do the load takedown, but I want to make the video shorter. So let's not focus on that. So this is, we find the unfactored load, that is the serviceability limit state. So I will use 500 and here, let me remove this calculator. You can see our reactions. So I'll come and call it load, which is load 1. So my column is just 1. So LF, we're going to use just this 0.9 here, and then for ultimate, I'm going to use 1.2, 0.9 and 1.2, and P is basically from Staad Pro is reaction along Y, that is 572.285 kilonewtons. 572.289. X is 1.048. 1.048. Then Y 1.052. 1.052. Then mx, moment x is negative 229.8084. Okay, negative 229.0284. and then my is negative 20. So I'm going to change this. You can see this is in kip per inches. I'm going to change this into kilonewtons because you can see these only are in kilonewton meters. So I need to change that. So I'm just going to go to File, Settings, Display Options. I'm going to go to Structural Units. So this one I'm going to change into kilonewton per meter. Then I'm going to change all of them. I'm going to change into kilonewton per meter. Okay, and then I'm going to apply. And then here is still meters. I don't want to use. I'm going to use meters. Displacement. My displacement is meters. Then apply. Then OK. So wait a bit. Setting. Options. So I'm going to go to nodes. You see why annotation, section unit. So this one I'm also going to change into kilonewton per meter squared. Kilonewton, meters, meters, then apply, then OK. Then I'm going to go back, setting, going to force units, moments are in kilonewton meters, distance force is in using kilonewton meters, then apply, then OK. So now we have changed. The moment is now in kilonewton meter. So you can see the value was different. So it should be negative 25, right? mx should be negative 25.964. My should be negative 2.3, 0.2, negative 2.344, negative 2.344. So I'm not sure if there's anything. Okay, everything is okay now. So we can just go to, just click design. So it is failing because of SLS. So we can try to increase. We can try to increase the base length and base width to 2.3, then 2.3, then 2.3 minus 0.1125. So I'm going to go to calculator. 2.3 minus 0. Now it will be 2.3. Let me first cancel. So it will be 2.3 over 2, 1.115. Okay, 1.15 minus 0.1125 is equals, so 1.0375. negative 1.0375. So design. You can increase the base depth to 0.55. Design. So it's passing in overturning but failing in soil pressure. So we can increase this further to 0.6. Design. We can reduce it 0.5. 5. Design. So depth is this depth. So let me increase this one to now 0.25. 0.25. Then this one should be 0.6. We first check. Okay, it's passing, but now I want this to be right here on the very edge. So 2.5 divided by 2 is 1.25. So 1.25 minus 0.1125 equals to, so now it will be 0.1375. Okay. Now design. So let me check. And check if this one is about 400. So this one is just 500. Remember my rebar cover is 50 across XY, bottom and top, 50, 50, 50, 50. My soil matriculation is 22, my soil density is 18, concrete density is 25. Because I'm using class 25, just use class 20. Concrete density, yeah, that is okay. So FY. So let me check. Let me try 0.65. Design. 0.55. Design. So 0.6. 0.6. Then let us increase this 0.6. This one 0.6. So it's passing but failing in overturning. Okay. So soil cover, let us increase our soil cover to 1. Yeah, it is now passing. So let us try to bring it down to 0.5. 0.5. Soil cover should remain 1. Let us see. So just use 0.6 and then 0.6 and then increase this further to 1.2. Let us try 2.5. 2.5. So it is failing. Just I will just be 1.6. 0.6. Okay. So it has passed. Nothing is red now. Remember, you need to make sure that. Let us try to reduce this for 50. See. Okay. So visibility, let's just use 500. Design. So that is how our column looks like. That's how our column looks like. Our column on our base. Our base is 2.6, 2.6 square. So we can do the calculations. We can print this. But first of all, we can go to output settings. We can add recruitment sketch here and then OK. Then we go to bending, schedule. And then from here we can just let's use Y12. Let's use Y12. So let's enter Y12. See Y12 at 200. So it's less at 175. At 150, let's try at 150. Okay. We have to use Y16. So let's just use suggested. So this first of all should be not tab but column. Okay. Then this one here should be column and then use suggested. Now you can see the values are passed, they entered and they required. So the entered is more than the nominal. So it has passed. So it is both top and bottom reinforcement. So you can go now to calculation sheet. And then print it. Then print now. Okay. And now we can print and save it. So I will give it a name. I will give it www and then I will save. So it's printing. Don't worry. So this software only does it does not do analysis, so you have to have analysis results. So that's the only disadvantage. But if you have Staad Pro and you have Prokon, you can be able to integrate the two softwares, and that's the one advantage of Staad Pro. Integration with other software. So we have print. So let me check again where I saved this here. A revise www. So I'll go to. We can go to bundle schedule. Don't send. We can go to bending schedule. We can save this bending schedule. I just go to desktop again. revised, and then call it part 1, and then I don't know if I'm missing something, and then I will save. So you can check the 3D if you want. The 3D looks like that. Okay. You can print windows. Okay. So I'll save it 3D and then save. So Prokon will not do analysis for you. So you need to have the results, because when you come here, you have to input the results from the analysis. So that's the disadvantage of Prokon. But if you have Staad Pro, you have solved that problem, and now it will solve the other problem of designing eccentric footing. So we can now go to our desktop. Just open this. So you can see the parts. We can see. Let me open this. These are the calculations. Right. So everything now you can present your calculation how you did. You can take a photo of where you got your analysis results, and take a photo, present all these to your client or whoever. So we are going to do the same for now for let me go back. So I'll go to downloads, go to compressed, go to design spreadsheets, then open these. Then I'll open foundation part, that is RCC 4181. We are going to do just for Axio, for Axio base. Okay. So we're going to do Axio base for the same for this. So we're going to input the values. So let's say it's 2000, then this one is 225 by 350, and then let our height be just 500 is okay. So this one, my class of concrete, just 25. So I have, if you need to download this Excel sheet, I have included a link in the description of this video. You can just download it. So my cover is 50, my soil strength is 18 kg per meter square. My aggregate size is 20 millimeters, so no problem. My bearing pressure is around, is just okay, 190. So we're going to put these values. So we're going to put dead. So dead. So from just going to put 572. 572. Then this one just let it be 0. Then mx, our mx is -25.964. 25.964. My is negative 2.34. Negative 2.34. Hx is 1, Z is 1, okay? Just 1 and 1. 1, 1. So you can see we have a valid design at 12 H12 at 175 and then 12 H12 at 175. We can try to reduce this one to be just 1800 and then 1800. So it is failing. So we just need to use 2000. 2000. Okay, so this now is a valid design. So you can enable content so that you can print. Then you can now print. So just a revised, then calculation, Z, and then save. It's now printing. So the other way to print, if you don't see this option, you just go to view, and then macros, and then run macros. Okay, no problem. If you can't run macros, you just need to go here, right click, properties, and then you enable. There's an option I can't see here, so we just print with this. Just print it because we have this option. So you can see so our results are giving us H12 at 175. We can do the same with Prokon and compare and see if it's giving us the same thing. Alright? So let's do the same with Prokon. So let's say this one is now it does not exist, now it is 0. So now let's say this one is just 2. And of course everything remains the same. Let's design. So everything has passed. So let us reduce it. Let's reduce it to 1.8 or 1.8. Design. So in Prokon is maybe the issue is let's put 400. Still passes. Let's go down 1.7. 1.7. Design. Still passes. 1.5. 1.5. Design. This one is passing. Oh, okay. You can see the depth is 600 here. So there's a big difference. And then the soil cover is 1 meter. So let this be 0.75. And this depth is too big because in our Excel, remember our depth was 500. Now it should be 0.5. 0.5. So let's try 1 meter. So you can see it's failing. So at 200, 2 and 2. So the design is passing. Okay. So you can go to our schedule, then we don't need to stop reinforcement. So go to design. Actually, with using top reinforcement, that's another problem, because in Excel there is no top reinforcement, just bottom reinforcement. You can see just bottom 1 and bottom 2. So top reinforcement is only for eccentric. So no top reinforcement. So let me first calculate. And then go to this. Yeah. Now it has changed. So the required here is, the required here is 0. Suggested is 60. So here we should change to y12. Y12. You can see y12 is failing at 200. So this one is passing at 175, 175. So it should be, let's try 200. Even 200 is failing. So you can see Prokon is normally very comparable to manual. So this one I will delete. No, not required. Not required. Because now there is no eccentricity. So this one I will 175. 175. 175. Then this one is a column 175. Now you can see where the problem will come. So you will have to actually increase this. You have to actually increase this, because when you go to your bending schedule, you find so input, design, then calculate, and then bending, then this one. So my cover is, bottom is 6. Okay, so they are moving down. Number of links. So let me try it. It's not responding. So let me try to escape. So you can see where you will be, where the catch is. You find the reinforcement that is required is too much, so you have to increase. At the end of the day, you have to increase either your depth or your length and width. So let's go to input. Let's just use 1.55. Then design, calculation, so required, so it should be higher, the enter should be higher than the normal. So let's try 150. Now it is passing at 150. You can see where the catch was. So you cannot just put here any value. You have an end of the day to increase so that you can get the correct answer. So this one was 500. So let's design. Okay. So you can see it is now passing. So let's just use two because there is no any red, so it just passed. Complete and output setting. Okay, and print. Okay. Then just say come, then save. So then just suggesting 16. I need to use 12. So this is what we tell you that the load day is critical, so you need to use to increase the base length and the base width. So maybe we can try something. We can try to let me just delete this. Try to increase this to 2.3. I want it to be around to just 175. See if it is going to pass that. Stub height 1 meter. Stub height just maybe it's just 1 meter. Okay. Okay, it is passing. Calculation. So here our calculation. 20. Okay. I'm trying and 175. And 75. Still failing. So there's 150. So it's just the bottom reinforcement. So you can go to Iterative and just print this part. We are going to just save it here. Okay. Part 2. And save. Then so either way the Excel will tell you if you doubt your software, you compare it with Excel. So after that, maybe we need to go to analytical model and then view the whole structure. So if you want to select any other node, you just need to come to select node cursor, select view selected object only, selected objects, plan view, then go to post processing, then reaction. So you can just screenshot this, okay? Just screenshot. Just like that, and then you will explain where you got your reactions. Okay. So, the other thing you need to generate the detailing. So I just come to back to Prokon, then add and detailing, and then pads. Okay. Then you can go to file and then open. So you go to desktop, then list, just open, tab one, open. So we can save this. Save. You can print and convert this into EXL. I want to print EXL. I want a paper width is 494. This is A1 by 594. This is A1 size paper, right? So key save setup, okay, and then print EXL. Then I'm going to save it as Eccentric. And then save. So I can go back to my, then open Eccentric. So let's wait for AutoCAD to open. So I'm going just to hit escape in my keyboard. Just say yes, no problem. So I just close this one. I don't need, because this one I've already opened. So I just try to use this. So now you can see my detailing. Then I can just join. So now you can be able to detail. So to detail this is just simple. You just need to, you don't need to detail like this. I just say let me just copy one here. Let me just have another copy. So let's delete that. that, then delete that one, delete that one, and that one. So delete that one, delete that one, that one, that one, then put that, then that, and then delete. So I just edit this one. So it will be 2 times. So that one will indicate it is top and bottom. 2 times. Okay. So thanks guys. If you need the Excel, I have included a link in my description. You can download it. Thank you. See you in another episode.